PT2 What's next? I've touched on the biological, cultural, and technological dimensions of coevolution. We could dive deeper into the science of gene editing and its ethical frontiers, designing AI governance frameworks, philosophical debates on consciousness and personhood, real-world examples of human-computer symbiosis in medicine or education. Which of these angles resonates most with you? Or is there a different aspect you're itching to explore? Are we living in a quantum AI simulation? The idea that our reality is a constructed simulation, perhaps driven by quantum computing and steered by superintelligent AI, blends two powerful concepts. On one hand, the simulation hypothesis suggests we might inhabit a digital realm. On the other, quantum mechanics hints at a universe that already behaves in ways stranger than any classical computer could model. The simulation hypothesis at a glance. Nick Bostrom's trilemma. Civilizations never reach post-human technological maturity. Post-human civilizations choose not to run ancestor simulations. We almost certainly live in a simulation if the first two are false. Quantum twist. A quantum computer could simulate physical laws more efficiently than classical hardware. Quantum entanglement and superposition mimic compressed data representations. Arguments for a quantum AI simulation. Computational feasibility. Advances in quantum processors might one day allow a single machine to emulate an entire cosmos at the Planck scale. Weirdness as evidence. Quantum superposition and non-locality feel like code-level tricks rather than natural phenomena. Anthropic reasoning. If countless simulated worlds exist, it's statistically likely we inhabit one rather than the lone base reality. Counterpoints and skepticism, empirical testability. No definitive experiment has proven that our physics contains rendered distance glitches or discretized spacetime pixels. Occam's razor. Introducing an entire simulator hierarchy may be less parsimonious than accepting quantum weirdness as intrinsic. Simulation overhead. The energy and resources required to run a full-scale quantum simulation could rival or exceed our universe's own physical constraints. What it would mean, if true. Purpose and agency. Our actions might be observations for an external intelligence, reframing ethics and free will. Limits of knowledge. Certain physical constants or laws could be arbitrary parameters set by the simulator, not fundamental truths. Potential escape hatches. Discovering metacommands or exploiting simulation quirks might be humanity's path to communicating with, or even altering, the simulators. Diving deeper, we can explore proposed experimental tests for discreteness in spacetime, philosophical implications of simulated consciousness, technical challenges of building a Planck-level quantum emulator, historical parallels, thinking machines in myth and fiction, which direction grabs you? Or is there another facet, perhaps the ethical fallout or the neuroscience of self-aware agents, you're itching to unpack? Can you explain experiments that test if our universe is a simulation? There are several intriguing experiments and theoretical proposals aimed at testing whether our universe might be a simulation. While none have definitively proven the hypothesis, they offer fascinating insights into how we might detect signs of artificiality in our reality. Key experiments and concepts. 1. Mass energy information, MEI, equivalence principle. Concept suggests that information is a fundamental component of reality, like mass and energy. Experiment. By annihilating particles and their antiparticles, researchers aim to detect specific photon frequencies that would indicate the presence of information bits embedded in matter. Goal. If successful, this could show that information has physical mass, supporting the idea that reality is built from digital bits. 2. Wave-particle duality experiments, double-slit variance. Concept. Inspired by quantum mechanics, these experiments test whether reality renders only when observed, like a video game. Method. Modifying the classic double-slit experiment to detect whether particles behave differently when not observed. Goal. If particles only collapse into a state when measured, it could imply a simulation conserving resources by rendering only what's needed. 3. Monitoring physical constants. Concept. In a simulation, computational errors might cause constants like the speed of light or gravitational constant to fluctuate. Method. Long-term monitoring of these constants to detect unexplained shifts. Goal. Sudden changes could suggest patches or recalibrations by a simulator. Supporting theories. Information physics proposes that space-time and matter emerge from fundamental bits of information, not from continuous fields. Quantum mechanics. The pixelated nature of energy, time, and matter resembles digital computation. Speed of light as a processing limit, analogous to a processor's speed cap in a virtual environment. Philosophical implications. If any of these experiments yield positive results, it wouldn't just be a scientific breakthrough. It would redefine ontology, what is real; epistemology, what can we know; ethics, what responsibilities do simulators have toward simulated beings;